Hi, good morning, good afternoon, or good evening, wherever you've tuned in to this Capital Link webinar, which is part of the third annual Capital Link Decarbonisation in Shipping Forum. I'm Wiese Bockmann, Senior Analyst with Lloyd's List Intelligence, and I'll be your moderator for this panel, which will be examining carbon reduction, capture, and offset. There are high hopes that onboard carbon capture and storage technology can be scaled up for commercial use by the global fleet, as the hard-to-abate industry struggles to find different solutions to meet greenhouse gas emission reduction targets. Likewise, the use of voluntary carbon offsets is gaining traction, while the role of shipping in transporting captured carbon is taking shape. So we're here with me to add some clarity and update on the subject, 4 experts in their field who will be your panelists today. So first up, we have Panos Koutsourakis, Vice President, Global Sustainability, ABS. Panos leads the ABS Global Sustainability Centers of Excellence, the Global Gas Solutions team, and the Digital Sustainability team. Welcome, Panos. Next, we have Dr. Konstantinos Kyriakopoulos, co-founder and CEO of DeepSea Technologies. Konstantinos is a Greek entrepreneur, and his 6-year-old startup is developing artificial intelligence solutions for the maritime industry. So welcome, Konstantinos.
Good to be here, Michelle.
And to add to the confusion, we have another Konstantinos Stampedakis, the co-founder and CEO of ERMA First. With a process engineering background, Konstantinos is heavily involved in the development of marine equipment, which can provide us solutions to maritime environmental challenges. And to our last guest, Hauke Kite-Powell, Senior Vice President Managing Decarbonization at Marsoft. Hauke is a Senior Analyst for liquid gas shipping, and focuses on the liquefied natural gas and the liquefied petroleum gas tanker markets and trades. So welcome, gentlemen.
Hello.
So I'll say at the outset that if you're listening to this webinar, can you please send in your Q&As? We have prepared there, and we'll endeavour to get through them as we go through the panel. So I'll start off by asking, what is carbon reduction? How are we using carbon capture and storage and offset, and the role that it's taking in shipping? And I might start off with Konstantinos Stampedakis. If you could just run through briefly the details of this technology, and then I'll go to Hauke to talk about voluntary carbon credits and how widespread they're being used at the moment.
Thank you very much, Michelle. Good afternoon to everyone, or good morning, or good evening, from wherever you listen to this podcast. First of all, I'd like to thank you for setting up such a nice panel and for the interesting questions. Without any further delay, let me give you, a brief description of what a carbon capture is, and I will focus mainly on the post-combustion because this is what we are doing as ERMA First Group. So what this is, we burn fuel and we produce carbon. So we need to do something to capture this carbon. So the steps of the technology available so far, which is a mature technology in the shore industry, it's the following. Based on the actual CO2 reduction factor that each vessel has, the capture rate is determined. Based on this, a portion of the exhaust gas is redirected from the vessel's funnel into the carbon capture technology. The first step of this carbon capture technology consists of an exhaust gas pretreatment, where the temperature is adjusted, SOx is removed, nitrogen oxides are removed, and particulate matters are removed. The second stage of this plan is the actual carbon capture, where actually the pretreated exhaust gas is entering either a column or another device, where an aqueous solution of chemicals, mainly amine-based, is injected. This solution, actually what it does, it attracts and it captures the carbon. Therefore, the exhaust gas, free of carbon, is released into the atmosphere or back to the funnel of the vessel, while the solution, which consists of water, amines, and the CO2, is directed into another stage where we separate those three substances in order to reuse water and the chemicals, and then to either compress the CO2 and store it on board as a gas, because that requires too much of space and volume, or we carry on by compress it and cool it down in order to liquefy it, and we store it as a liquid on board the vessel. So at a glance, this is today's carbon capture technology, which is applied widely onshore, and eventually will be applied on board vessels when the technology will be marinized and mature enough.
Thank you. Now, I understand the technology is about 5 years away from being used commercially, and which we'll talk about later. But I'll just go to Hauke now to talk about voluntary carbon credits and their use and how widespread they are at the moment.
Thank you, Michelle. Welcome, everyone. Carbon credits, voluntary carbon credits, are a mechanism by which ship owners can get some revenue, some income for investments that they make to reduce carbon emissions that go beyond normal operating practice. And it's important to realize this is different from the regulated carbon markets like the European ETS. This is a market in which individuals and corporations voluntarily buy offset credits in order to offset emissions that they cannot avoid themselves, like air travelers, for instance. The funds from that purchase of those credits can go to ship owners to help offset the cost of investments in making their ships more fuel efficient. And there's a lot that can be done today to do that while we wait for carbon capture and other zero carbon fuel technologies to mature. This is something that Marsoft has been working on very hard for the last several years, and we're working now with a number of owners to make informed decisions about retrofitting older ships, making new buildings more fuel efficient, and taking advantage of that incremental revenue from carbon credits to help make those investments viable.
Now, of course, as somebody who sat in at the Marine Environment Protection Committee at the International Maritime Organization last week, it's quite obvious that there are more stringent targets coming and that the commercial viability of these zero emission fuels is yet to be fully established. Hence the role for these technologies, especially with onboard carbon capture. What sort of role do you think it will have in the shipping decarbonization voyage? If I throw this question over to you, Panos.
Yeah, thank you, Michelle. This technology is going to be in high demand, what we say, and the demand will come only for the existing fleet. The existing fleet, in order to comply with the future regulations and the current regulations that need to let's say, to reduce the emissions. Among the technologies, carbon capturing, it seems to be a viable solution for that one. There are several technologies that are pre-combustion, post-combustion, oxide technology. I would say the post-combustion, like Konstantinos mentioned previously, is one of the most mature technologies. It's something that tested in the past onshore. There are many, let's say, heavy emitters onshore that they're using carbon capturing technologies. And now we're transferring this technology on board the ships. Of course, is a different environment, but we're working on this direction. There are several companies that they're developing the systems, and there are pilot systems on this one. So back to your question, yeah, it's going to be very important But still, with the carbon capturing, we're facing the same challenges as the alternative fuels. And the challenges is coming to the infrastructure and the downstream. So that means the technology, we're quite confident that it's going to work properly. On the other hand, we need to work on the infrastructure development and how to offload the captured carbon from the ships. This is something that we need also to develop.
So how much carbon would be maximum stored on a vessel before it has to be discharged? Because this is the problem. There's no infrastructure for the carbon to go offshore, which will affect the voyage trajectory and the types of ships that can take this technology.
Yeah, it depends. It depends on the profile of the ship. What I want to say for the existing fleet, if we have a vessel that is, let's say, for instance, 15 years old, and the owner is planning for another 10 years lifetime of this vessel. So we have to assess, we have to estimate what is the required amount of carbon to be captured in order to comply with the regulations. So in some cases, might be 20%, 30%, or even 50%, but we wouldn't expect to go up to 100% for the captured carbon.
Okay, now I'm going to move to you, Konstantinos K. One of the measurements of carbon so far and greenhouse gas emissions generally has been tank to weight. That is from the fuel once it gets on board the ship through to combustion. But the new regulations that are coming in, certainly from being at the IMO last week, is that we're now having well-to-wake measurements of emissions. So how does that add complexities to the carbon offset and carbon capture picture?
So first of all, I mean, I would say that tank to weight is not solved. I mean, right now, the standard for reporting CO2 is self-reported daily vessel reports of how much fuel they consumed, which is then multiplied by a factor which seeks to estimate the carbon content of the fuel type. I think it's well known within the industry that these reports are generally not very accurate, even when there's, the crew is honestly trying to report the fuel that's consumed. It's very difficult to estimate that accurately. A daily total is not representative of exactly what's happened over the day. And then there are a number of reasons why there are various perverse incentives to not report it accurately. Now, when you add in well to wake, you're essentially distorting the picture, even more, because a much larger number of entities are involved in reporting, and with everything that goes into ships, where there's always a lot of uncertainty about where the fuel has come from and so on, the calculation becomes even more complicated. So I actually think that if you want to do something, if you want to do carbon accounting in shipping, there's a lot of work that needs to be done in terms of incorporating sensors, high frequency data, accurate data, reporting mechanisms, before you can, trust any of the numbers that come out. We're very behind on this.
Yes, sometimes the calculations tank to weight to well to weight can impact the economic feasibility of some of these carbon reduction technologies. I know that that's something probably that Hauke's been working on. I've just got some questions here from the audience. The first one is probably, you can address this, Hauke, at the same time. Is it not an issue in general to store the carbon? Can you explain this further? Also, which methods of carbon capture cost less and are most compatible with ships?
Okay,
Sure. Yeah, I think on that last point, Konstantinos can probably answer better than
Sure.
I can. But just quickly, I agree with what Konstantinos K said about well to wake. It's complicated, but it's ultimately the only meaningful measure. And so we have to grapple with those complications somehow. And anytime you simply reduce consumption of fuel, which you can do by investing in energy efficiency technologies today, you are by definition reducing well-to-wake emissions across the board. In CCS, the S is very, very important. What gets done with that carbon after it leaves the ship is critically important. And so, but I'll let Konstantinos speak more to the technical options there.
Yes, Konstantinos, S.
Yep, thank you. Thanks for this question. Definitely storing the carbon on board is as challenging as capturing the carbon. Actually, there is a sweet spot, and this is about physics and thermodynamics between temperature and pressure, and this is about 20 to I would say 17 to 20 bars pressure, minus 20 to 25 Celsius, where CO2 is liquid with a density equal to water, so equal to 1, which is the most efficient, let's say, form of CO2 in order to store it on board. Definitely, when you calculate, we ran several feasibility studies. One which comes into my mind now, it's a medium-sized vessel which consumes about 25 tons of heavy fuel oil per day, and has a ballast voyage, and it has voyages of 15 to 17 days. We have calculated that we need a storage capacity of 400 tons of CO2 at a capture rate of 22%, 22 to 25%. Definitely there is a challenge. It is one of the many challenges that the industry should solve, because onshore space is not an issue, while on board is one of the biggest issues. But definitely, so far, there are solutions as long as identify locations where we can store 1 or 2 CO2 tanks. And we have seen already some vessels equipped with such kind of cryogenic tanks for storing CO2 on board. And also, we have seen designs of CO2 carriers, which proves that the technology is already there. And when it comes to the last part, cost less and most compatible with ships, that depends. A means or a mean-based solution looks the most promising and viable technology for deep sea going vessels, while carbon or I would say asbestos, or how they call it, calcium oxide technologies are more suitable for ro-ro vessels and passenger vessels.
Thank you for explaining that. Another question we have, it relates to capital expenditure for onboard capture carbon and storage, which is between 40 and 70% of new building costs. I've actually seen numbers of 40%. I haven't seen a 70% figure, but still quite substantial. That tends to indicate that the economic feasibility of onboard capture carbon and storage is under question. What's the panel's views on whether or not it can be a viable alternative once it's commercially available in about 5 years' time? Who would like to take that question? Panos?
Yeah, I'm thinking, of course, I think maybe the expertise here, Konstantinos from Marsoft, because they're developing the technology, but I wouldn't expect to be so expensive, in my view. And definitely, we have to define, and we have to understand where we're going to use this technology. As I mentioned initially, we're speaking mainly for retrofits at this point, at this phase. And we have to compare which other technologies are available for the same savings, for the same carbon reduction. So we have to compare with alternative fuels technologies. We know that, let's say, retrofitting a vessel either with LNG or other type of alternative fuels might be very expensive. So also from few feasibility studies that we have done, it seems that using carbon capturing technology that requires additional energy to be consumed on board the vessel. So we have to be careful when we're estimating the net energy profit, let's say, for this technology in order to capture the carbon. But it seems that there is a viability, there is going to be a viable solution. There is some work, some extra homework to do for that, but it seems, but maybe Konstantinos, maybe you can add more on this.
Yeah, sure. Let me add to this. First of all, I agree with Panos. This 40 to 70%, it sounds rather high. From our calculations, we don't expect something, less than 5 to 10% of a new building cost. And we've seen, based on 100 euros per ton CO2 cost in the EU ETS, that there is a return of investment within 5 to 7 years. So from commercial perspective, carbon capture is viable. From technical perspective, we have many steps to go through.
So
if I may, just quickly put that into context. So I think ultimately with carbon capture, you can achieve higher rates of emission reductions than with, shall we say, currently available retrofits like premium coatings, wake flow improvement devices, engine optimization, and so on. But the cost there is also lower. By our estimates, you can reduce emissions on a ship significantly, certainly up to 15%, maybe better, with those currently available technologies at a cost of $20 to $50 per ton. And so I think that is certainly a step we encourage owners to take while they wait for things like CCS to become mature.
So I've got a study here from the Mercer McKinney Muller Center for Zero Carbon Shipping, which reviewed 2 applications. And that study concluded that a larger new building vessel was best suited with abatement costs of between 180 and 260 dollars per ton of CO2 for very large crude carriers on a tank to weight basis. And then that cost rose to $220 to $290 per ton for a different type of well to weight calculation. Does that add to your calculations about viability in the future? Hauke?
Yeah, I am not familiar with that study. I'll have to take a look at it. The abatement cost for all these processes rises as you increase the rate at which you're trying to abate. So it's relatively low for the first 10%, and as you push toward 100%, it rises sharply. So it's important to look at those numbers carefully and see exactly what point in the curve they're looking at.
Can I ask Kostas K, your views on this and the scalability on those figures?
I mean, I'm not really an expert on the economics of carbon capture. I think maybe that's again a question for the other Konstantinos. So.
I apologize. Yeah. But vessel optimization.
But in terms of in terms of vessel optimization, I think what I'll kind of say again is this. I think it's very good that the industry is making these long-term plans, both in terms of carbon capture and in terms of reduction technologies, retrofits, wakes, and so on. The main issue I see is that at the moment we lack a good framework for measuring what's actually happening on board the vessel and more broadly. And the result is that decisions are being taken inefficiently and actually evaluating the outcomes of these decisions is often difficult. So I'll give you an example of a case study we did with a major charter. They spent several million installing wake equalizing ducts on a couple of vessels, and they had a study which showed that these reduced fuel consumption by a certain percentage. And they had already done it, and they asked us to use the data that we were collecting from the vessel before and after the installation in order to quantify exactly what the saving could be. Now, what we found is that what this duct did is it took the power speed curve of the vessel and it kind of shifted it like this. And the result is that there were some speeds where the fuel consumption was increased and some where it was decreased. It turns out that the operating profile of the particular vessel was actually almost exclusively at the speeds where the fuel consumption was increased. And so this investment actually resulted in the carbon efficiency of the vessel decreasing for most of its life. I think every vessel is different. Every vessel's operation is different. And what we look into at DeepSea is helping owners actually optimize the operation of the vessel day to day and the actual individual decisions. And I think this needs to be taken into account, and it needs to be in place before you start spending huge amounts of money on any kind of new technology. And so there definitely needs to be a combination of kind of digitalization with these other interventions. I know, for example, the ERMA First has invested quite a lot in digitalization technology as well. And so I think that's, the right approach. Do the long-term thing, but also invest in the data infrastructure to be able to understand what you're doing.
Well, this might lead on to another question we've got from the panel, which is, to what degree will emissions data need to be shared throughout the value chain in order to satisfy well-to-wake reporting requirements? Who's going to put their hand up for that one?
I can take that.
Yeah.
One. Very, very important. In my view, what you really need is you actually need to measure the CO2 directly, right? I mean, if you're not doing that, then you're opening up all sorts of holes in your measurement of the tank to wake part, right? I mean, well to wake, again, I'm not an expert in. I know there's all sorts of assumptions you can make, but again, because those are one-off things, right? So like once you've bought whatever it is what it is. I think you're maybe a bit safer in using an assumption. But in terms of actually operating the vessel day to day, you really need to be measuring it live, because every vessel is different, and you can end up making the wrong decisions and releasing more CO2 than you were trying. Short of measuring CO2 directly, at a minimum, you need to be measuring your fuel directly, right? So you need to have a flow meter, ideally a mass flow meter that is also tracking what type of fuel is being burned, either indirectly through temperature or through flow meters per tank, etc. And so this is something that the vast majority of the fleet doesn't have. It's not that expensive. I mean, you could, I think, with maybe 50,000-60,000 dollars US, you can retrofit a vessel with everything you need to be able to measure fuel. And then that needs to become part of the reporting chain, right? So that needs to be going to the regulators rather than the new reports, and then also it needs to be more transparent within the industry. So from ship owners to charters, in the S&P of ships, right? If you're buying a ship, do you not want to see the actual performance of the ship that's come from the data that's collected? At the moment, the standard is no. Insurance, in terms of negotiation of charter party agreements. So huge disruption that has to take place in terms of accurate data being measured and then becoming part of the conversation in the industry.
Another question we have is, would the captured carbon be kept in separate tanks above deck? Is that one for you, Panos?
Yeah, definitely it's going to be kept in separate tanks. Of course, it depends on the product. Sometimes can be, it depends, can be solid, can be graphite, depends on the technology, what is the carbon product. yeah, it's going to be, but definitely it's going to be on a separate tank. That is clear.
And what about issues for disposal of carbon dioxide? We sort of talked about that a little bit earlier. It's considered waste. It may not, present regulations perhaps don't allow for it to be disposed on shore. How is that going to be solved? Is anybody working on that?
Yeah, I can add on this one. Yeah, there is ongoing work, to class, let's say, this carbon disposal, carbon offloading. In principle, there is the London Protocol that it doesn't allow to trade, actually, to trade carbon from one country to the other country, because that may be considered as a waste. But of course, there are some bilateral agreements between countries that start accepting, trading the carbon, because speaking about the carbon is not only the carbon capturing, but is a whole carbon economy. It's a whole economy that is emerging. And yeah, there is a capturing, there is storage, offloading, transportation. Currently, we're speaking about liquid CO2 carriers, which is going to be part of the equation. And I would say that, let's say, about the carbon capturing, the transportation is going to be a big part, because the carbon capturing, we're expecting more and more on the onshore side for this one. Sequestration is part of the equation. There are many projects in North Europe. They're working on Northern Lights project for carbon sequestration. So it's something ongoing work. We're expecting to find some solutions and class the carbon at a level that can be moved and offloaded.
So tomorrow's very large crude carriers could actually be carbon carriers. That's the tanker of the future.
Yes, definitely. The carbon carriers, we're expecting to be liquid CO2 carriers. Yeah, it's going to be the carriers of the future, definitely. For the future, we're expecting to see different type of vessels. Just to open up a bit the discussion, is not only liquid CO2 carriers, but more dedicated ammonia carriers, hydrogen carriers. We're expecting to see that. But the carbon is going to be part of the blue economy. Blue economy, everything, when you have a fuel production that in between is getting the carbon capturing, and then is getting the blue color code on this one. And that is going to be part of the whole energy transition. And
yeah, how widely adopted does anybody in the panel expect onboard carbon capture to be within the carbon economy? We talked a little bit about its feasibility, but in 5 years' time, will this be something that nearly every ship owner will be considering? Like they made the decisions that they had to make economic decisions about scrubbers, for example. That's sulfur dioxide abatement systems for those.
I think that the trajectory is there. We have seen that the carbon capture as part of a whole strategy, and I agree with what Hauke said earlier, that the carbon capture will be the last step that the ship owner should take. Okay, after applying nice silicon-based paintings, nice energy efficiency device like air lubrication, kites, flattened rotors, whatever is available, propeller caps, and then you will install a carbon capture if you're still missing some percentage of the carbon. With that in mind, we've seen many ship owners today having real interest on this last step. Therefore, we believe that it will be a solution. It seems to be a viable solution from a commercial perspective. It's up to us now, the technology providers, to make it feasible from technical perspective.
Yeah,
I think that's right. Sorry.
I'm sorry, go on.
No, I was just going to agree with what Konstantinos said, and I think it is the degree to which it's ultimately adopted across the fleet will depend also on the future trajectories of zero carbon fuels. The carbon capture is relevant so long as you're burning fuels that emit carbon. To the extent that owners ultimately shift to other non-carbon fuels, that will reduce the penetration rate of the technology in the long run. But it's an important piece of the transition for sure.
I was going to mention that at last week's International Maritime Organization meeting, they introduced some interim checkpoints for greenhouse reduction emission strategies. And one of those included using other technologies in addition to zero carbon or near zero carbon fuels. So I'm guessing that opens up onboard carbon capture as a more viable alternative with the inclusion of that language in the revised strategy. Another question I had for you, Hauke, was what is the cost per ton of voluntary carbon offsets? We mentioned the European Emissions Trading Scheme price of about $100 per ton at the moment. Where does the cost of these voluntary carbon offsets sit?
Yeah, that's a really good question. And there's no simple answer to that because the voluntary markets are not unified. There are different perceptions in those markets about the quality, so to speak, of different credits. We expect that maritime-based, carefully documented emissions reductions like the ones that we're working on will provide a net value to the owners around $5 per ton over time. And that is much less than the cost of carbon in the regulated markets, but it is a meaningful contribution to the return on investment in retrofit energy efficiency devices and modifications to the ships. So it doesn't pay for those investments, but it's an incremental revenue stream that can reduce their profit, increase their profitability and reduce the payback time to owners.
Well, thank you, Jim. And can you believe it? We've come to the end of the session. That 40 minutes has just flown by. We still have some questions to have answered, but no time. So can I just thank every one of you, Panos, Konstantinos, and Hauke for making your time available today and for sort of shedding some excellent insight into a reasonably unknown section of maritime decarbonisation story. So thank you once again, and for those that attended, and see you later.
Thank you, Michelle. Thanks, everyone.
Thank you, Michelle. Thanks, everyone. Bye.